Okay guys, welcome back. Today we're going to carry on from integrating with exponential functions into integrating reciprocal functions, and this will involve our logs. Let's go back. One of the ones that we had problems with was finding the area under this curve where that's y equals 1 on x, let's say from 1 to 2. Right. The way that we knew how to do it was we went, well, the integral of 1 on x dx equals, that's x to the minus 1, integral of x to the minus 1 dx. And then we did our little power thing and we went x to the add 1, 0 on 0 plus c. And when I got this, crazy pen, divided by 0. So that didn't work. Luckily, everyone's favorite thing, logarithms, are going to come to save us. If I take y equals ln x, I know that dy dx equals 1 on x from before. So I could then say that the integral of 1 on x dx equals ln x plus c. Easy. So now, just from knowing how to differentiate ln, that shows me how to integrate 1 on x. So I can go back to this example over here. We can say, well, the integral, to find this area here, from 2 to 1, integral of 1x dx equals ln x from 2 to 1 equals ln 2 minus ln 1. Now, we can evaluate that in the calculator, okay? And we get ln 2 is something, ln 1 is e to the power of something is 1, 0 equals ln 2. And I just want to point out here that our log laws will be used some of the time. I did that by putting it in, but using log laws on this step here, I could also say that that's ln 2 over 1 equals ln 2. Okay, that's a different way of doing it. We've got this guy here, okay, and now I just want to extend that to make it a more general case. We also saw that if y equals ln f of x, I said that dy dx equals f dash x on f of x. Now I know in the other ones we kind of did it for a singular, then we did it for linear, then we did it for any function, but I think we can just skip the linear here because a linear function is just a function. So the integral of f dash x on fx dx equals ln of fx plus c. Now that is the real hero for today, okay? This is the simple version. This is the one we're going to use. What we want to look for is the derivative sitting on top of the original function. Then I can just jump to my answer. Alright, so here we go. Let's make some more room there. Okie dokie. I'll probably just do 2 of these, okay, just to save a little bit of time. 5. Integral of 5 on x. Integral of 5 on x dx from e squared to e. I want 1 on x, okay? I can take this 5 out, remember? Rip him through that s. So that will be equal to 5 times the integral of e squared on e of 1 on x dx. I know, that's a little bit small there. I know that this is 5 ln x from e squared to e. And now subbing in e's and lins, this is fun. 5, and I mean that. 5, I'll put big brackets on, okay? Ln e squared minus ln e. Now, ln e squared is 2 ln e using our log laws. 2 ln e minus ln e. 2 of something minus 1 of something is 1 of something equals 5 ln e. What's ln e? E to the power of something is e equals 5. Oh my god, that's amazing. Where can we do this a little bit differently? Maybe from this step here. I just want to point out that these can be done in different ways, okay? This could become, let's just see if it works, 5 ln e squared on e. Yeah? Because it's a minus, I can divide, which will be equal to 5 ln e equals 5 times 1 equals 5. So when you apply your log laws, it doesn't matter. Okay, you can apply it at this line or at this line and we'll get the same result out. I'm only going to do b and then we can move on, okay? So we've got, what do we got? We got integral, back to blue for our standard one, 4 1 on 1 minus 2x dx. Now I'm not using, I don't have any c's here because they're definite integrals. Alright, I want f dash x on top. What's the derivative of that denominator? Minus 2. So I'm going to go 4 1 something on 1 minus 2x, and this is where I do my little magic. I put a minus 2 there, and how do I cancel that out? Well, I need that. Then it's the same thing. Now we're in the form. Here we're in the form f dash x on fx. So I can go straight to my answer now. Minus a half ln 1 minus 2x from 4 to 1. Right. And now I'll leave those little bracket there. I'll leave that substitution for you to do, and maybe the same one there. It might not be as nice because see how we had the e's at the bounds here? E's and lns work well together. Maybe it would be nice. You'll find out. Next guy. Alright. Now this is more in the functions of the previous example was linear. I just want to get away from linear ones. So here I've got the derivative of the bottom here is 2x, and I've got 2x on top. I'm done. This is really nice. Otherwise I wouldn't have had no idea how to integrate that guy. But it says ln x squared plus 2 from 1 to 0 equals ln 3 minus ln 2. And that'll do. Ln 3 on 2. I don't know. Maybe. Whichever one you like. Maybe that second one. Okay. B. Again, I'll leave C for you because it's the same process really, isn't it? Okay. Integral 5 for x on 9 minus x squared dx. I want my derivative on top. I'm doing this in one line. I'm just gonna, I want a minus 2x on top because the derivative of the bottom there is, let's call that, if that's y, If that's y, then y dash equals minus 2x. Okay, so I'll write it out again just so we're not messy on the video, well, not too messy. I want a minus 2x up top. I'm big with the minus 2's today. Minus 3 up on this one, minus 3x squared. Yep. Equals from, so I'm doing my integral now. I'm going to say minus a half ln 9 minus x squared from 5 to 4. I'll let you do the substituting in there, and we might move on to the next one. Okay, before we move on to the next one, I can see a couple of things wrong with this. Alright, bit of a trick. First thing, what do I want it in the form of? I want it of f dash x on f of x. What's the derivative of the bottom? The derivative of the bottom is minus 3x squared. How do I get that 3x squared on top? This is good because I was going to talk about this later, so it popped up now. 3x, 1 minus x cubed dx. Okay, simple. I want a minus 3x squared. I'm going to times by x. I'm going to divide by x. Nope. Okay, you cannot bring a variable out the front. We can only do that with constants. So this question here is a good example of something that we can't do yet. Okay, we're going to need more tools later. There's another issue with this question that I see. Without drawing it, I can see that he's got an asymptote at 1. And my integral goes from 0 to 2. I can't do this. I can't integrate over an asymptote. When we're at the start, we won't do this. Well, it's not going to work anyway. But if I look at y equals 1 on x, if I want, let's say I want the integral 1 on x dx from minus 2 to 2. That's all this area here, and this is going to keep going, and I can't. It's going to keep going. I can't integrate across an asymptote. Let's do half of that even. Let's do the integral from 1 to 0 of 1 on x dx. So I only want, that orange bit. Let's see if that works. Bring that down a bit. Equals ln x from 1 to 0 equals ln 1 minus ln 0. Ln 1, e to the power of 0 is 1. E to the power of what is 0? No, this does not work either. So you can, if you do both sides, it might spit out an answer, but it's not going to be correct. If you actually integrate on the asymptote, it's not going to work. Okay, so on this example, they actually want us to integrate ln x. Now we haven't done that. We've integrated 1 on x. Okay, that was fine. That was ln x. Now they want us to integrate ln x dx, which is essentially finding the area under that guy from somewhere to somewhere. Let's say that. All right. They've stepped us out how to do this. We'll come across this later on, this kind of example, but good to practice actually. A really nice one. Differentiate x ln x by the product rule. X ln x. dy dx equals, a wee bit more room we might be needing, dy dx equals product rule, hold one, differentiate the other, it's the derivative of ln x, plus hold one, differentiate the other. Dy dx equals 1 plus ln x. Now it says show by differentiation that x log x is... I'm just going to do that same step that we always do. If the derivative of that is that, the integral of that is that. So the integral of 1 plus ln x equals, dx equals x ln x. Now, I want this guy in here. I want the integral. I want that. So what we're going to do is split that integral. And we can split integrals. So this is the integral of 1 dx plus the integral of ln x dx equals x ln x. And I should have a c here, guys. Plus c plus c. Sorry about that. Alright. So, x plus the integral of ln x dx equals x ln x plus c. Now I can just subtract that x over there. Integral of ln x dx equals x ln x minus x plus c. And that's what is up here. Use this result. So this is a really nice example, guys. I encourage you to definitely work through it yourself. They want my bounds there. What have I got? E and 1. Integral between E and 1. That means I'm not going to have that C. And it's going to be just that. And let's just go over to the right there, so we don't have to start a new screen. Equals E ln E minus E minus 1 ln 1 minus 1. Now that is equal to, do I have to, no, I'm going to do it above, this is terrible, equals E ln E. E to the power of what is E? That's 1. So it's E times 1 minus E minus ln E to the power of what is 1? That's 0. 0 minus 1 equals E minus E is 0 minus 1. 1. My God, that's amazing, isn't it? Look at this picture up here. That's this here from 1 to E is exactly 1 unit. Wow. 1 unit squared. Woo. Okay, see ya.